if I started with this, would you agree that f of x is the same exact thing as y? So it's just y equals the absolute value of x. You guys remember what that kind of looks like? Sketch it if you remember it. On a graph, sketch it. That is a V shape. It looks like that. Raise your hand if you had that one right. Awesome. Now, three forms of this. One is the equation, one is the graph, and there's a third representation, and that is a bunch of points. Got to make sure you can do all three. Would you find me some points that are on that? Hint, you can put in anything you want for x. Figure out what y value you get. Like if you put in x is 0, you get y equals 0. 0, 0. And that's one of the points, see? Some more points. Dice of destiny. Who should I call upon? Row 6, person 2. The new guy that seems too cruel, so I'll call on Savage. Tell me another point besides 0, 0 that is on this graph.
1,
1, 1. Another one?
and -1,
-1.
and 1.
1. Very good. That'd be these. Do you get that's probably enough? You kind of get the idea here? All right. Now, what if I wanted to move the whole thing up 1? What would that have looked like in each thing? If I had wanted to move the whole thing up 1, would that have put a +1 somewhere? Yes. On the inside or the outside? Outside. And then, think about it. Did I just change all my x values, or did I just change all my y values? The y values would go one bigger. See, y equaled something, but it's bigger by 1 on every case. So I would have added 1 to all my y values. So this would turn into 1, this would turn into 2, this would turn into 2, 0, 1, 1, 2, 2, 2. See how it all shifted up 1? Does that make sense to you? All right. Now, the hardest thing about today is that you get confused about what they're asking. Like, you'll be looking at the problem and you'll be like, not sure I understand what they really want me to do here. But in every case, it comes down to this. You're going to be taking one of these parent things like an x squared, and in weird different ways, they're going to say, move it to the right 1 and down 4. Let's say I said that by just using words. Right 1 and down 4. Would you know how to write it now? I would. Would you know how to write it? Not graph it. The equation. Just write the equation for it. If you know it, write it, and then please compare it to the kid next to you. Make sure that they have the signs right, like pluses and minuses, because a lot of people goof one of them up. Particularly important. Since this is the word that you guys talk. So could you slide a little closer to each other? So you're not so far away. Now, talk about it. See what you think. Okay. Maybe you should like introduce each other. All right. Here's what I hope you knew. Right 1 goes like this. It seems like that's to the left 1. If you know what you're doing, that should be counterintuitive. Like that should feel wrong, but that's correct. And then down 4 is a -4 out here. Raise your hand if you had that one right. Awesome. Now, when you get lost today on what they're asking, it's all about this. It's all about writing a function so that it's been moved left or right and up and down. I don't even think we're doing the hard ones today, like stretching it, which, by the way, I'm getting you ready for the future. If I put a 7 there, do you get, that's an outside and therefore a vertical 7? And then it's not like an up 7. That would have been out here. So it's a times by 7 on all the vertical things. And do you get that those are the y's? I would be taking all my y values, which used to be here, and making them 7 times bigger. Does that make sense to you? That is what happens. Well, all the y values get 7 times bigger if I put a 7 there. That's called a vertical stretch. But we're not going to have those today because today is easier than that, thankfully. All right. So what's another way we could do it? Sometimes we do it with pictures. And we say, here's f of x. Everybody copy this down. It'll be a pretty easy one. It's just going to be like this little mountain that starts like this. And what if I say, I want to take that whole mountain and I want to do this to it? Do you get, I just told you to move it in 2 different directions? Which way did I tell you to move the mountain? Is that 3 right or up or down, or what the heck is it?
Right.
That is right 3. How about the 1? Up 1. Do you get, if I needed to, I could take this and I could move it to the right 3 and up 1. So I take every single point on it and move it 3 to the right. Let's say 3 is like that far. And up 1. Every single point, right 3, up 1. This point, right 3, up 1. And I could now have my new triangle. Make it wavy. My wavy triangle got moved right and up. That makes sense to you? All right, so sometimes they're a picture and they're telling you which way to move it. Sometimes it's an equation and they're telling you which way to move it. Sometimes it's points. Everybody write this list of points. 2, 3, 3, 3, 4, 3, 5, 6, 6, 6. Now, could you graph those? Sure you could. Would they pass the vertical line test or not? Well, let's graph them. Take a second. Graph those points. Is it illegal to pass? No, it can fail the vertical line test. It just won't be a function. So maybe this thing won't be a function. Like the functions have to pass a vertical line test. We'll see. Over 2, up 3. Put a dot. Over 3, up 3. Over 4, up 3. Over 5, up 6. Over 6, up 6. Those are my points. If I connected them all, does it pass the vertical line test? If you've forgotten what that is, it's basically drawing a vertical line through it and seeing, does it ever touch twice? This one passes the vertical line test, so this is a function. All right, so I've got my little function. Now let's say I wanted to move it up 1. Which of my numbers are going to change if I want to move it up 1? The y's. Do you get, we trust the y stuff. So you would just add 1 to all of them, and everything would move up 1. If, on the other hand, I had wanted to change the x, as in move it left or right, do you remember the deal where I said you can't trust the inside of the function? Like if I said y equals x minus 5 squared plus 8, you'd be like, I see a minus 5. It feels like it should be left 5, but it's actually to the right 5. You know, remember, it's counterintuitive in there? Okay, so if I said to take this weird little red shape and do something with its x, be careful. If I said to move it left 1, it might feel like that you should subtract 1 because that's kind of the left direction, but you actually add 1 to everything. I'll show you what I mean. Here's my f of x, and I want you to move it left 1. I'll put a plus 1 in there. Do you agree that that is telling me to move this to the left 1. Does that make sense, first of all? Okay, now I go over here. Should I actually then, as I look at this, should I actually add 1 to all of the x values? No, because it's counterintuitive. So what should I do to all the x values? I should actually subtract 1 from all of them, and that's what would make this little funny shape move to the left. Counterintuitive. That's really, really hard, because you like expect to go this way and it actually goes that way. You know, there's actually somebody who made a bike that when you turn the handlebar to the left, the bike turns to the right.
Oh.
And it is so hard to ride that thing. But even though if you know it's backwards, it's like impossible to ride, because you're like, you know, I want to go to the right, and you just, everything in you wants to move this handlebar to the right. Instead, you got to move it to the left. And apparently it takes some people a really long time to be able to ride that bike, because everything's opposite. Well, that's what the inside is like. That should feel like it goes to the right one, actually goes to the left one. Should feel like you should add 1 to all the x's, so you subtract 1 from all the x's. Okay. All right. There's a big intro. So now, let's make sure that you get, what about if I make one function eat another function? Everybody write this out. F of x is equal to 2x minus 1, and g of x equals x squared. I want you to look at that, f of g of x, and I want you to tell me which one got eaten and which one was the predator function and actually did the eating. Yes?
The G got eaten.
The g got eaten. Yep. It's almost like you're seeing through it and you can see inside of the f beast that he ate a g. Now, can you make... And the functions actually take these and make the f function eat the g function. There's only one place that it could live. It would go inside his stomach, and that's like the x. Would you agree that somewhere in the ocean today, a big fish ate a smaller fish? Probably 1 billion times today, right? Now, that bigger fish that ate the smaller fish, do you get he in turn could be eaten by a bigger fish? Jump. The big tuna just ate the fish that ate the other fish. That is like f of g of p of x. A function ate another function, then got eaten by another function. Does that kind of make sense to you? I wonder in one day what the most number of this is that has ever happened. Like some tiny little thing got eaten by something bigger, which then got eaten by something bigger, which then got eaten by something bigger, and eventually it's like a shark has eaten them all. And like, I wonder if it was like 16 nested fish. Possible. Yes?
So I think, I don't know if anyone else knows this, like, there's like a little song.
Oh, I know which one you're going. Yes. No, wait. I was thinking of Baby Shark.
It's like one of those nesting dolls.
Yes, it's like one of those nesting dolls. Okay, good. So, moral of the story, you're going to do a lot of that in this class, where the one function eats the other function. So math-wise, we take the f function. I'm going to copy it right here. 2, and instead of the x, I put a big empty stomach because he's got to eat the other one, which is this one. And that goes in there. Now, if I slap a y equals at the front of it, do you get, now I have a parabola that has got 2 changes to it. This one's the easy one. It's down 1. Down 1, I know we've done a lot of left and right, but that's not left and right. Do you know what it is? It's up and down. But what's that 2? Is it moved up 2? Times 2. That's called a stretch. Since it's on the outside, it's called a vertical stretch. That is a vertical stretch with a factor of 2, and this is moved down 1. This is vertical stretch. I'm just getting you ready for that tomorrow. It's probably not going to happen too much today, but one function will definitely eat another function today. All right. So let's go the other way. What do you mean? Well, this time the g is going to eat the f. So I'm going to move this all down. Now I want g to eat the f function. Role reversal, the little fish eats the big fish, which can happen in math. So this time take g, make it eat f. So here's g, x squared. I make a big empty stomach for x, and he eats the 2x minus 1. Gonna want to slap a y equals at the front. Now, tricky one, there's high vo. Do you remember me saying that before? Do you remember what the high stands for? Horizontal on the inside. What's the vo stand for? Vertical on the outside. There is nothing vertical happening. There's just this. Do you remember me saying that stuff on the inside is counterintuitive? Does it seem like it should move to the right and you got to switch that and therefore it moves to the left? Does that make sense to you? This part? That should mean... Oh, wait. I think I got it backwards in my own head. That should seem like it's to the left, it's actually to the right. Do you agree that it is moved to the right? Okay. All right. Then how about this times 2? Doesn't it seem like it would get twice in the wider direction? Horizontally, twice as big? Actually, half as big. So hard to do everything backwards. So this thing gets half as big and moves to the right. All right. Last thought. Let's say we take one that has been not even stretched, just moved. That one's moved 8 to the right and up 1. And let's make some points. If you can't make points for a graph, you will fail this next test. It's on there so many times that you have to be good at making points or you're toast. So, let's make a few points. Okay, I start with 0. Bad idea. It's going to go off the graph. Because right off the bat, when you put in 0, you're going to end up with negative 8 squared, which is 64. Do you think I'm going to give you a grid that's got 64 spots on it? No. So, it's not like it's illegal, it's just you can't graph it. So, what's a better number? 8 would be a genius number to put in. Stick in x as 8, and you'll get an easy y value. And then hint, if 8 was good, things near 8 are going to be good. Like 7 would be good. Like 9 would be good. So pick a few more. Find me 3. No, actually in the real world, you're probably going to have to graph 5 points to see where a parabola goes. Otherwise, here's what happens. You graph 3 points and it's like this. And you're like, well, I don't know where the parabola is from those 3 points. It might go down like way down here and come back up. I don't know. So 3 points is not enough. 5 points would be fine. So let's do 8. And I said 7 would be smart and 9 would be smart. And then let's just do 2 more points that are kind of close to 8. We're doing 7, 8, and 9. So maybe 6, 7, 8, 9, and maybe 10. Those would be 5 smart points to pick because they're all kind of near 8. All right, find those answers quick. I'll hit pause and figure out those answers. And then we're going to graph them. So if you're already done finding those points, awesome. Start to graph them. So a ton of people, when they look at the key on this, are going to be confused by how the key does it. I personally think the way we did it is the fastest. We go directly to the right answers. The key, instead, makes the kids graph the original parabola, a whole bunch of points of that, and then makes them move all those points to the right 8, and then makes them move all those points up 1. to me, going directly to the answers is a lot faster. But if you're looking at the key and you're wondering what the heck is going on in the key, they start with the original points of a parabola, and then they take each of them and add 8, opposite of minus 8, to their x values, and then they add 1 to all the y values, and that's how they get their answers. My way of just putting in an 8 and seeing what you get, 8 goes with 1. Ken, would you read me the rest? 7 goes with what? 9 goes with? 6 goes with? 5? And 10 goes with? Do you get that if you graph those points, it's going to be direct to the point? If you just graph those, you're going to not have to make a whole bunch of points and then move them all and then move them all again. You just get to go directly to the answer. To me, that's just a superior way to do it. But if you're looking at the key, that's what they're doing. They make a whole bunch of points that are in the normal position for a parabola, and then they move them all, and then they move them all again. Okay, let's start your homework. Everybody find the homework. I will tell you some that you can skip. There'll be quite a few because it's biggish, but it doesn't need to be that big, so... All right. 1D is a skip. I've got a list right here on the board. I'm going to only tell them verbally for those that are watching the video. You're skipping 1D. All of problem 2. Problem 3C. Problem 5C, problem 6C, problems 8, 10, and 12. So why am I having you skip so many? Because that keeps it reasonably sized. I also know that teachers fall into a trap of, well, I want them to be well prepared, and then they give them an assignment that's so big that the kid has to pick between doing that and doing science, and then they're like, well, I can't do it all, so I guess I won't do my math. If I keep the math assignments small enough, then I think you'll do them. So, that's my trade. I'll cut them down. You actually do them. Because see, if I cut them down and I post a key, and then the kid still doesn't do the homework, then I'm like, well, then they're not even trying. If I gave them a lot smaller assignment than it would have been, and I post the key for it, then I know missing work is just a sign of they must have something going on in their life, because they could have absolutely done my homework. It was doable, and the key was posted. All right, so on that note, I am going to post the key. But don't let that hold you up from coming up and asking, because some of these are confusing. All right, let's actually start with number 1 then. Would you please read me number 1, James?
Question.
Oh, sorry, James Welsh. The very first problem. Is it a drawing or what does it say?
Simplify each expression. If y equals fx equals x squared, find f parentheses x plus 1.
Now, what are they asking you to do? I told you before this would be tricky until you figured out what they were asking you to do. Aren't they just telling you to stick x plus 1 into the function? That's all they're asking. So, stick x plus 1 where? Well, where are the x's? So x plus 1 goes in there. So you got x plus 1 squared. And now, note, you might think you have to multiply that all out. Actually, I wouldn't say that you would have to, because I like it just the way it is. I can tell that's a parabola that's been moved 1 to the left. There's nothing that much better about it being all multiplied out. Do you get what I'm saying? So do you have to multiply it out? Nope. On the test, this would just be in what's called vertex form. And I want a side note, make sure you get this. Pay attention for the next 1 minute. If you don't do anything else all hour, pay attention to this. Do you agree that on a parabola, the vertex, the spot where it makes the turn, is the most important spot on a parabola? Because if you know where that is, I can even just put a dot there and then you know, well, if that's the vertex, it either goes this way or goes that way. Like it's super powerful. Well, here's the vertex. It's buried right here, and whatever's out here, that is the vertex. In this case, it's -1, 0 is my vertex. Do you get how I knew that? -1, 0. It's because it's the opposite of that, because you can never trust that, and there's a 0 out there. If there's nothing else out there, look, -1, 0. I'm going to show you a couple more. Y equals x minus 9 squared plus 2. The vertex, 9, 2. Why'd you change the one sign and not the other? Because I don't trust this, and I do trust that. The vertex of this is that. It's really powerful. And by the way, little known fact, absolute value graphs have vertexes too. You know how they're V-shapes? That's still considered the vertex. And if I had that one, it would have been an absolute value graph that got shifted like 4 to the right and up 2. And look, the vertex from that, I could have just looked here and known it was 4, 2. See how that's handy? It's a guaranteed point that's on your graph, and it's the most important point. Okay, so being able to find the vertex easy will help you on this assignment. All right. So this one's in vertex form, and I could have got the vertex from it, and it would have been -1, 0. Okay, that's number 1, part A. I know that you can do this yourself, and I'm also going to post a key. So please, if you get stuck, though, there was lots of kids last hour that got stuck. You'll be normal if you get stuck. But what's really sad is that some of them just get stuck and don't ask. Please, if you get stuck, come up and ask. It shows me you care.